Welcome to NASA STEM EPDC Quick Bits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Hi everyone, I'm Dr. Samuel Garcia Jr. from NASA's Kennedy Space Center. The title of today's activity is Sound on a String. The main goal of this activity is asking questions and defining problems. Together, we will explore the importance of developing questions in science. Asking questions and defining problems in K through 2 builds on prior experiences and progresses to simple descriptive questions that can be tested. The objectives of this activity are: ask questions based on observations to find more information about the natural and/or designed world, ask and/or identify questions that can be answered by an investigation, and finally, define a simple problem that can be solved through the development of a new or improved object or tool. In this activity, students will rotate between various workstations to formulate a hypothesis of how sound travels. They will also experiment with cups to determine the best method to transmit sound on a string cup phone. NASA's Commercial Crew Program is working with the American aerospace industry and private companies. Together, they are developing a new generation of spacecraft and launch systems capable of carrying crews to low Earth orbit and the International Space Station. How is a rocket launch? Like a rock concert? If you have ever witnessed a rocket launch in person, then you know the roar from the engines during launch can be heard and felt miles from the launch pad. Sound is a form of energy caused by vibrations. The tuning keys on a guitar adjust the tension on each string and thus change the pitch or frequency of vibration. The guitar string vibrates more slowly when it is longer, resulting in a lower frequency or lower pitch. Pressing the string against a fret reduces the length of string vibrating, resulting in a higher note. When an object such as a guitar string, rocket engine, or speaker vibrates, it causes the molecules in the object to move back and forth. Neighboring particles push into each other and then return to their initial position. Think of a slinky stretched out across the table. With one end fixed, give the other end a small push or pull and watch the disturbance travel along the length of the slinky. This exercise demonstrates a compression wave and illustrates how sound energy travels. This chain reaction causes surrounding molecules to vibrate. Sound is not only transmitted by vibration, it is also detected by vibration. Sound waves traveling through the air enter the outer ear, causing a thin membrane called the eardrum to vibrate. The vibration travels through the middle ear to the liquid-filled inner ear. There it is channeled to the cochlea, where specialized cells convert the compression waves into electric impulses transmitted to the brain via nerve fibers. The title of today's activity is Sound on a String. In this activity, you will be exploring different questions to help you formulate a hypothesis for how sound travels, and then experiment with different types of cups, cup sizes, types of string, and string lengths to determine the best method to transmit sound on a string cup phone. You will need the following materials. Like scientists and engineers, we ask questions to develop solutions to different problems. In this activity, we explore the importance of asking questions to help us understand complex phenomena and develop a model to show how sound travels. Adults, encourage your students to develop more questions to help improve their understanding of the concepts presented today. For example, you can ask them the following questions. I'm going to give you an example of a hypothesis. I think the plastic material will give us a better sound. I think that the 2-meter string will give us a better sound. Now it's your turn to formulate a hypothesis. Rotate between each workstation and write your results down on the activity question sheet. For the first step, you are going to need an adult to help you. Poke a hole at the bottom of the cup using a pointy object. Insert the string through the hole at the bottom of the cup. You will probably need to tie several knots to make the first knot larger to prevent the rope from sliding through the hole. Repeat steps 1 and 2 with the second cup. If necessary, use a paper clip or button to help keep the string in place and prevent it from sliding through the hole. Stand far enough away from your classmate so that the string is stretched tightly, and whisper into the cup as your classmate puts his or her ear close to the opening of the cup. Now, think about the string that connects the 2 cups. What works better, tight or loose? Why do you think so? Now that you have tested your design, think about the following question. How well did it work? Did you hear your classmate's voice clearly? What other changes will affect the quality of your design? Adults, you can use these questions to help strengthen your students' understanding of the engineering and science concepts related to today's activity. We challenge you to ask other questions to foster your students' curiosity and creativity. We hope you enjoyed today's learning experience. Please do not forget to fill out the information you gathered on the worksheet. If you do not know how to write, you can draw what you saw at each workstation.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.